Today we cover gas stoichiometry. So how to calculate volumes, moles and masses in reactions involving gases. So in the previous videos we talked about Boyle's law, Charles' law and Avogadro's law. So without wasting much of the time, let's dive into the game. So now, to understand gas stoichiometry clearly, we should start with a reference of what? Of Avogadro's law. In Avogadro's law, we said equal volume of gases at the same temperature and pressure contain equal volumes of molecules, which means volume was directly proportional to the number of moles, which is V is equal to volume and any number of moles. Now, when you are talking about gas stoichiometry, in gas stoichiometry, we use the moles and mole ratios from the balanced chemical equation to calculate volumes, masses, or moles of gas. So that's the concept. In gas stoichiometry, you use moles and mole ratios from what? From balanced chemical equation to calculate volumes, masses, or what? Or moles of gas. So an example analog that we can take is if two balloons of hydrogen react with one balloon of oxygen. So what's going to be there is we are going to say that if two balloons of hydrogen, you're getting the point, two balloons of hydrogen react with one balloon of oxygen, you're getting the point there, the ratio of volume is equal to 2 to 1. So as you can see here, it's 2 to here there's only one atom, so it's 1. So that is the mole ratio. So in gas stoichiometry, we use the moles. For example, we have the moles of hydrogen and the moles of oxygen. And the mole ratios, what are the mole ratios? These two and the coefficients. So we can understand this through an example. Now, this example tells us if 5 liters of hydrogen react with excess oxygen at the same temperature and pressure, what volume of water vapor is produced? So as you can see the question on your screen there. So we want the volume of what? Of water that is what? That is produced. And we have been given the volume of hydrogen. We have been given, what about oxygen? We haven't been given the value of oxygen. So let's go ahead and solve. So step 1, use mole ratio from the balanced equation. From the equation, as you can see, the equation there is, so that's the equation, 2H2 plus O2 is equal to 2H2O. Now, we have been given that 5 liters of hydrogen, react with excess oxygen to produce what? At the same temperature and pressure, what volume of water vapor is produced? Now we want the volume of water vapor that is produced. So step 1, use the mole ratios from equation, from the balanced equation, and the mole ratios is 2 moles of hydrogen, and 2 moles of water. So as you can see, it's 2 moles of hydrogen plus 2 moles of water. So for now we ignore oxygen. Now we have been given that this hydrogen, we have been given the value of the volume of water, which is of hydrogen, which is 5 liters. So we put 5 liters there, but we don't know the volume of water. Now the game is just simple. We just put volume 2 here and we just cross multiply for us to find the volume of water. So here we go. I have just did 5 liters, which is the volume, times 2 moles, which is equal to 10 liter mole over, this is 2 moles. So we are just going to remain with liters in terms of units. So what are we going to have? We are going to have 5.0 liters. So that's the volume of water that we are going to have. So as you can see, I just used what? I just used the mole ratios, which is the 2 moles and the 2 moles here, and the volume. So even sometimes you can also be given that to calculate the volume of oxygen, maybe that was reacting, because you have the volume of water, of hydrogen here, even the mole ratios. As long as you just have one volume, it's easy for you to find another volume. So let's go ahead and solve example 2. So here the second question. So we have nitrogen plus hydrogen reacting to produce ammonia, which is 2NH3. Now they are asking us how many liters of hydrogen are needed to react with 2 liters of nitrogen at the same ATP. Just as I said earlier in the example, they can also ask you in another way, whereby the reactants. So we can see that we have been given the liters of nitrogen, and we need the liters of what? The volume of what? Of hydrogen. So what do? We just do just as we did last time. We put the mole ratios first. So the mole ratio is 1 to 3. 1 is for what? 1 is for nitrogen. 3 is for what? Is for H2. Now, what about the volumes? We know that hydrogen is the one we are looking for, which is this is N2, this is H2. Now, we know that we are looking for hydrogen, and for nitrogen we have 2. So, which is equal to what? This one is just going to be the volume of what? Of hydrogen. So again, we just multiply, we cross multiply. What are we going to have? We are going to have volume of hydrogen is equal to 2 times 3, which is 6.0 liters. So at the end, our volume of hydrogen is going to be 6 liters. So that is the volume needed to react with what? With 2 liters of nitrogen at the same temperature and what? And pressure. So that's how we solve. That's how we find volume. That's how we find the number of moles when we're talking about gas stoichiometry. So let's go ahead and do example 3, which is a limiting reactant problem. Let's go to example 3. So there is our example 3. So we have CH4, which is methane, acting with oxygen 2O2 is equal to carbon dioxide, which is CO2 plus 2H2O, which is water. Now we are being asked that 4 liters of CH4. So we have methane, which is CH4, having the volume of 4 liters, and react with 6 liters of oxygen. Which gas is limiting? Now they have given us, now we just need to know which one is limiting and how much carbon dioxide is what is produced. Now, how do we calculate? How do we find which one is limiting? So for us to calculate this, the step 1 that we are going to take is compare mole of volume ratio. Let's compare the volume ratio. Now here is how we are going to start this. So we are going to see, since oxygen here is having 2 and methane is having CH4, then we see we have 4 liters of methane react with 6 liters of what? Of oxygen. So what we are going to do, the required volume of oxygen needed is going to be this 4 liters of methane. 4 liters of methane, you will multiply it by 2. Why are we doing that? Because when we compare the mole ratio is 1 to 2. Now when we put the volumes, we know that for oxygen it's 6 liters, but we need to find out what's the required. This one is the available, but what is the required volume? For that for us to find that, we put 4 liters here and we put volume of what? Of oxygen here. So, and again, oh sorry, this 2 is for oxygen, so so it's 1 to 2, which is 1 is for methane. So where there is 1, that's where we put 4.0 liters times the volume of oxygen. Now this value of oxygen that we are finding the volume is the required volume. So when we multiply, we are going to find the volume of oxygen that is required is equal to 8.0 liters. So if the amount of the volume that is required for oxygen is 8 liters and we have 6 liters available, what does it mean? It means O2 is limiting. Why is it limiting? It's limiting because we have 6 liters available, but what we need is 8 liters of what? Of oxygen, and that makes oxygen the what? The limiting reagent. We can also do the same for methane to see what's needed and compare it with what's available so that we can see what's a limiting reagent. But we have already found it's oxygen because we need 8 and we have 6. But just for the sake of understanding, let's solve also for what? For methane. So we have 1 to 2. 1 is for methane, 2 is for what? 2 is for oxygen. And for now, we go with oxygen. We put 6 to oxygen And now we can see that when we put a volume of CH4 here, what are we going to have is V2 is equal to 6 divided by 2, which is 3 liters. Now, unlike oxygen, we are going to see that for oxygen, what was available is 6 liters, but we needed 8 liters. But for here, we are going to see that we need 3 liters, but we have 4 liters, which means it's in excess. So that's why oxygen is the limiting reagent. Now, since we have found the limiting reagent, we know that the limiting reagent is the one that is going to determine the amounts of product that's going to be produced. So now we can calculate the question is saying how much carbon dioxide is produced. So we are going to have what we are going to say is 2 moles of O2 is equal to 1 mole of CO2. And also for the volume of oxygen is what? The volume of oxygen is 6. So we are going 6 volume is 6 liters is equal to what? X. Now we just do cross multiply. So it's X 2x O2 is equal to what? 6 liters. So over 2. So the volume that we the volume that is going to be produced for oxygen is 2 into 6. It's what? It's going to be what? 3.0 liters. Therefore, the volume of carbon dioxide that is going to be produced is what? Is 3 liters. So that's how we solve or how we determine the limiting reactant problem. So that's how we solve it. So having solved that example, let's go ahead. This one I'm just going to give you even the final answer. For this one, we are solving a non-standard temperature and pressure with what? We are finding fine volume of 0.5 moles of gas at 300 K and 2 atm. So here we just use the ideal gas law. This one is non-STP, which is it is not at standard temperature and pressure. So there we go. We use the ideal gas law, which is PV is equal to nRT. Then we just make V the subject to the formula. Then we calculate the V by just substituting the formula. We know that the number of moles is 0.5 and the R is 0.0821. It's a constant, and temperature is equal to 300 K over 2, which is the pressure, and the answer is going to be 6.16 liters. So thank you guys for watching, and don't forget to hit the subscribe button.